Welcome to Software Minimalist channel. My name is Piotr and today I will talk about the theory of constraints. Every professional wants to be productive. If you are not productive, you are wasting time and money. But what does productivity mean? Is it measured by number of meetings or hours spent coding? Every manager wants their employees to have 100% utilization. Some want even more than that. Now, is this a good idea to require your employees to work at 100% utilization? On the surface, it might sound good, but what if I told you it can lead to your company going bankrupt? Yes, in fact, if every employee works at 100% utilization, it is guaranteed your organization will fail. How is this possible? Let me introduce the theory of constraints. It's connected to lean manufacturing and was introduced by Eliahu Goldratt in his book, The Goal. A very important book which software engineers should definitely read. In the book, the main character Alex Rogo needs to save his factory from being closed. Turns out in the factory where everyone was working at 100% utilization, the profitability was low and falling. Besides this, the factory was packed full of intermediate work in progress, half-finished inventory. Nobody knew who is doing what and why, yet everyone was busy. An awesome coach, Henrik Nieberg, created a wonderful video about this very point a couple of years ago, and I always remember it when coaching my teams.
This represents a feature or a customer request, and this is a team. And for them to build a feature, everybody has to touch the ball. Actually, it has to pass through all your hands. All right? Is that clear? And then when you're done, you just put it here. That's customer delivery. Right? So we're going to demonstrate this. Go. Look at them work. Awesome. Wow. Customer delivery. Cool. Right. Let's do another one. Go. Amazing, amazing team. Cool. And here's another one. Look at that. Awesome. Okay, here we go again. Pause. All right. Now, suppose the manager walks in. It's 10:15. The manager walks in, opens the door, and he looks in, and he sees that. Okay? And then he walks out again. Okay, and we keep going. Play. All right. Next thing. Pause. Now the manager comes in again later on that afternoon and he happens to see this. And he starts to wonder, what are these guys doing? There's 3 idle and 1 working, right? What a waste of resources. So we need to solve this problem. And the way we're going to solve it is by hiring a supervisor. And his job is to make sure that we keep people busy so we get value for our money. All right? So same routine as before. You have to touch every ball with both hands for it to be done, right? This time I'm just going to keep people busy. Ready? Go. Right, there's one for you. Oh, here's a hand that's available. Oh, available resources there. Right, here's one. Oh, got to keep people busy. Cool, that's great. Right, here's another one. Oh, I see a hand there. Okay, pause. Cool. Now what happens when the manager comes in? What does he see? Problem solved. Look, everybody's working really hard. It's great. We're getting value for the salaries we're paying, right? It's perfect. Except for one problem. The customer is like, where is my stuff? Right? So what just happened? In the first scenario, we had about maybe 10 to 15% resource utilization, right? Only 1 hand was at work out of the 8, something like that. And the flow time was somewhere in the order of about maybe 5 seconds, as in how long time it took to actually deliver a ball, right? Second scenario, we had resource utilization 100%, maybe even more, right? And our flow time was, well, infinite. We never actually got anything done. So here we have a happy customer getting stuff delivered. Here we have angry customer getting nothing delivered. So what does this mean? We should just ignore resource utilization and only focus on this? Well, not really. It is actually okay to tweak resource utilization, but after we've established our optimum flow. So we're going to look at that. And a really good technique for doing that is called pull. So let's have a look at pull. So here's what we had before, right? First scenario, 1 ball being passed through, right? This is push because I'm pushing in stuff, right? I'm pushing in another one. There's push, pushing it in. So pull means turning that around and saying instead of me pushing work in, I'm offering work to be pulled. which means that they can pull stuff whenever they feel they have capacity. They choose how fast to pull stuff in, right? So watch what's going on now. Right? Keep going, and I'm going to press pause. Right, so if we look at this now, what actually happened? All right, so what's the difference? Well, more stuff delivered in the same amount of time without sacrificing flow. So let's go back to the board. If we add another column here, throughput, some would call it velocity, we have about 12 or so balls per minute, right? 12 or so balls per minute. In the second round, well, we didn't get anything delivered, so it's 0. In the third round, what actually happened was we had about the same flow through time. We didn't sacrifice any flow time. But we improved resource utilization. We got it to maybe about double, right? About maybe 30%. And our actual throughput would be maybe 24 or so balls per minute. Right. So this is what happened. We optimize flow first, and then we optimize resource utilization without sacrificing flow. That's the kind of lean approach. So in summary, a lot of organizations get stuck because they focus way too much on resource utilization, keeping people busy. And if you focus on keeping people busy, what you get is a bunch of busy people. The lean approach is focus on flow primarily, and then resource utilization secondary. And one way to do that is through pull. 100% resource utilization equals 0% flow. So think about that next time you're stuck in a traffic jam because the road system is 100% utilized.
Really great video. Remember to go to their channel and give them a like. If you focus on making people busy, what you get is a bunch of busy people. If you instead focus on the flow of value, optimize it, then the teams will not need to work at 100%. Probably mostly firefighting, for you to get most of the value out of your value stream. In Lean, this practice is called one-piece flow, focusing on vertical completion of a single item before moving on to the next. It makes measuring throughput very easy. This is also the reason why Kanban recommends work-in-progress limit of about 5 items. Coming back to the book, it took the realization what is actually important to save the factory. What is the goal? The goal was not just to produce, but to sell the items the factory created. Not just make them, not just store them, sell them to customers. And the customers will only buy what they want to buy. Only that what gives them value. The value stream was not the production, but also the selling and getting paid. Therefore, local optimizations of the production flow or even individual steps, if they were disconnected from the ability to sell and optimize the vertical throughput, could lead to devastating results for the organization. While optimizing the small, you need to think about the impact on the whole. The factory previously was producing things that were not demanded by the market, thus increasing the inventory. And the growing inventory, besides taking up space and processing throughput of the factory, also required dedicated storage, which needed to be rented with money. This again decreased profitability, and nobody noticed because every single manager at every single station was interested in increasing utilization of that one station. Everyone was very busy and nothing was getting done. Besides this, what was important was the unit throughput in the factory and the demand for the products themselves. Increasing the throughput and assuming that demand was not saturated would result in a direct increase in profit. Now, how to increase throughput on the things that customers actually want to buy? You need to map your value stream. You need to understand what are the individual steps needed to manufacture your products and how much time is required in each step. Also, how much time is spent waiting. You might be waiting, for example, for other products to go through the same process. Maybe those are products which then end up on the shelves gathering dust, and your profitable gadget is just blocked. In the case of software, the individual steps can be requirements gathering, development, compilation, unit testing, integration, functional testing, packaging, deployment. You probably also need to loop in some of these steps. For example, development and unit testing will be a loop where you need to spend some time iterating until your code works correctly. Now imagine one of these steps, let's say functional testing, requires significantly longer than any other step and has some kind of maximum number of changes allowed in the repository before no more commits can be made. Let's imagine the development takes 30 minutes of active work and looping with unit testing. And at the end, you have code you integrate for another half an hour, and then you kick off the automated functional testing, and that takes 12 hours. In a situation like this, the biggest influence on the speed of your development is not the coding practices, your efficiency while typing, or anything you do directly. It's the functional testing which is slowing down the throughput of your continuous integration pipeline. An exercise of creating a value stream map allows you to see what is the active time versus the wasted time and waiting time spent in each station in your production flow. Using the example I mentioned, we would see there is half an hour for development, 10 minutes for unit testing, another half an hour for integration, and between these there is no waiting until the station is ready because it's just your laptop. But then the next step is the automated functional testing on the testing server, which takes 12 hours, for which time the server is running a Jenkins job and no changes can be made in the source. And not only that, you can only run it after working time is over because the tests are so long and require so much processing, they cannot be run during the day. So after a round of morning work, you have about 5 hours spent waiting for the tests to even start. What do? Do you continue working on another story? More untested commits? Maybe work in progress? Assuming the steps after the functional test take about half an hour each, we get half an hour plus another half an hour plus 12 hours plus half an hour plus half an hour. That's about 14 hours of cycle time, which means a piece of software can be considered done and delivered if in fact your value stream contains continuous delivery, once every 14 hours at most. In reality, even less frequently than that. Let's say it takes at least 24 hours for code to be considered done. Now, this doesn't take into account any bugs you would find through functional testing. The waste of time is multiplied with every loopback. One bug means 48 hours, 2 bugs means 72 hours, etc. A lean approach based on theory of constraints teaches all quality assurance measures should be moved much earlier in the value stream and focus on prevention, because repeating the same work multiple times is the single biggest waste of effort. In this example, it doesn't matter how big the code change is. To fit in the half-hour development time window of the thought experiment, it would need to be quite small. Let's imagine a single line change. A single line of code taking at least 24 hours to complete, with the assumption of no bug after the pipeline is finished. Can you see the throughput constraint? Now the main idea. In every system, there is always at least one constraint reducing throughput. How do we know there must be at least one constraint? Because otherwise the throughput would be infinite. Now, why would we not want to have people working 100% utilization before the constraint? Because they would only be producing a constantly growing pile of work in progress, since we are unable to push it through the constraint. This would artificially increase the complexity in your organization, add noise, and lower visibility. Why do we not want people to be working 100% after the constraint? Because they are starved for work, as everything is backed up at the constraint. We want the constraint itself to dictate the speed at which work in progress is provided at the input. Secondly, we want to optimize the throughput of the constraint whenever we can. And in the case of software, it is frequently possible, and frequently quite straightforward. Wouldn't it be good to have the entire software value stream take hours instead of weeks? From requirements entering the backlog to a done software iteration and valuable increment in days, hours, and minutes, instead of weeks, months, and years? Do you have requirements sitting in your backlogs for years until people forget where they even came from? Are people in your organization afraid of deleting these kinds of work items? Are your backlogs measured in hundreds of items? Does your organization understand its own value stream? The ideas of lean manufacturing, understanding the flow, optimization of throughput, value stream mapping, and removing waste are universally applicable in any industry, including software. They helped revolutionize ways of working and provided 10 and 100-fold increases in profitability. They are the fundamental basis for ideas like continuous integration and delivery, along with scientific method, quick learning cycles, minimalism, and empiricism. Read the books The Goal, The Phoenix Project, and The Unicorn Project, and change the overly complex, noisy, command and control culture of your organization. Adopt value stream mapping and the idea of pool to understand what your goal is and how to optimize it as a whole. Thank you all for joining me today. Please like, subscribe, and share. Provide super thanks or Patreon support if you can, and have a beautiful day. Until next time, your software minimalist.